let's talk about adding and subtracting radicals. This is sort of the second half of simplifying radicals. It's actually a lot easier than simplifying. So when it comes to adding and subtracting radicals, the first thing to realize is that we're going to treat radicals like variables, like an x or a y. Anything that's a radical basically gets treated like having a variable or an x on it. Think about how we used to combine like terms for any variables. For combining like terms, all we're really looking for is to figure out what it is that matches between different terms. For example, 2x plus 4x gives us 6x. 3x minus 2x gives us 1x. And 5x plus 2y, well, that just gives us 5x plus 2y. When we're looking at this, we're simply looking at what matches. In this case, 2x and 4x and 3x and 2x, they share that x term. They're the same. In the third example, we have an x and a y. They're not alike. They can't be combined. The same thing is going to happen with radicals. That is to say, 2 times the square root of some number, in this case we'll say 5, plus 4 times the square root of 5 can be combined into 6 times the square root of 5 using the same basic pattern. Let's look. So there are two steps in figuring this out. Number one, to combine, both terms have to have the same number underneath the radical. That is to say, if you have some problem, such as 3 times the square root of 3, and you're adding it to 4 times the square root of 3, because the number under the radical is the same, in this case 3, they can be combined. They share the same like term, in this case radical 3. The second rule is that you have to add the coefficients and leave the number in the radical the same. So go back to our example. 3 radical 3 plus 4 radical 3. Well, we already said that the numbers under the radical are the same, so we have the square root of 3, so that matches. We've met condition 1. And our coefficients are 3 and 4. So we can add 3 and 4 to make 7, and we're going to leave the number under the radical the same, square root of 3. That's it. 3 radical 3 plus 4 radical 3 gives us 7 radical 3. As long as those values are the same, you can just add them all day. The big goal is really to remember that when you're combining these, you have to treat the radical like a variable. It has to match the others in order to combine. Let's look at one slightly bigger example. Here's our example. Square root of 48 plus 12 square root of 12, or 2 square root of 12 minus 4 square root of 24. This is about as hard as it gets. We have 3 separate radicals that have different numbers. In order to solve it, we're going to have to simplify each of these radicals and then combine everything that we can. Let's do it. So 48, if we look at our perfect squares, can be broken into the square root of 16 times the square root of 3. 16 times 3 is 48. We'll add that to 2 times, well, square root of 12 breaks into the square root of 4 times the square root of 3. And we'll subtract 4 times the square root of 24, which breaks into the square root of 4 times the square root of 6. Next step, we've got to simplify each of these. The square root of 16 is 4, so we get 4 times the radical 3. We can add that to 2 times 2 times radical 3, because the square root of 4 becomes 2. And we'll subtract 4 times 2 times radical 6, because once again, radical 4 simplifies to 2. Let's combine all these like terms. So we get 4 times radical 3 plus 4 times radical 3, which is 2 times 2. And we'll subtract 8 radical 6, because 4 times 2 is 8. Next, let's look and see what can we combine, what matches up. In this case, radical 3 matches on the first two terms, and we can combine them. We'll take our two coefficients, in this case 4, Add those together, get 8, and we'll do 8 times radical 3. And we're subtracting 8 times radical 6. If we look at this next line, we'll notice that our two radicals are different. They no longer match. We're done. This is our final answer. 8 radical 3 minus 8 radical 6. That's it. That's all we have to do is simplify each radical and then combine everything we can together.